Welcome to Maths for Matrix, South Africa's #1 destination for grade 12 mathematics. Today's lesson is about sigma notation and series, under the topic sequences and series, on the grade 12, CAPS, syllabus. Please be aware that this channel only focuses on pure mathematics and not mathematical literacy. If this video helped you out, please leave a like, and subscribe so that you never miss an upload. And be sure to spread the word about this channel so that we can help as many grade 12s as possible. So, let's get started. What is the definition of sigma notation? Sigma notation is defined by this equation. But for us to understand sigma notation, we first need to know what sigma is. So, what is sigma? Sigma is this symbol right here. It is a Greek symbol, and it means summation. This n represents the upper limit of summation. We can say in layman's terms that this is where the series ends. This 1 represents the lower limit of summation, or we say that it is where the series starts. K represents the index of summation. And tk will most of the time be the general term of a sequence. But be careful because it might take up several forms. And this is a series. Now, let us define sigma notation. The sum of the first n terms of a sequence is given by the sum of tk, from k is equal to 1, to n, where n is the upper limit of summation, k is the index of summation, and 1 is the lower limit of summation. If you have the sum of tk, from k is equal to a to n, and n is greater than or equal to a, then n minus a plus 1 is equal to the number of terms. Definition of series. What is a series? Given the infinite sequence T1, T2, T3, until Tk and beyond, the sum of the first n terms of a sequence is called a finite series or the nth partial sum of the sequence and is given by T1 plus T2 plus T3 plus the sum of the next consecutive terms until Tn. And as shown above, this series can be written in sigma notation as the sum of Tk, from k is equal to 1 to n. The sum of all the terms of an infinite sequence is called an infinite series, and is given by the sum of tk, from k is equal to 1 to infinity. Infinity is represented by a sideways 8 symbol. Arithmetic series. What is an arithmetic series? An arithmetic series is the sum of the first n terms of an arithmetic sequence, and is denoted by Sn is equal to n divided by 2 times 2a plus n minus 1 in brackets times d, all in square brackets. The sum of the first n terms for an arithmetic sequence can also be given by Sn is equal to n divided by 2 times a plus l in brackets, where a is the first term of the sequence. D is the common difference between the terms, and L is the last term of the sequence. Finite geometric series. The sum of the first n terms of a finite geometric sequence. A, AR, AR squared, AR cubed, AR to the power of 4, until AR to the power of n minus 1, can be written as the sum of AR to the power of k minus 1, from k is equal to 1 to n. And it is equal to a times 1 minus r to the power of n in brackets, divided by 1 minus r, where r is not equal to 1. The sum of the first n terms of a finite geometric sequence can also be given by a times r to the power of n minus 1 in brackets, divided by r minus 1, where r is not equal to 1. Infinite geometric series. When r is between -1 and 1, the infinite series a plus ar squared plus ar cubed plus ar to the power of 4 plus the sum of the next consecutive terms plus ar to the power of n-1 and beyond has the sum a divided by 1 minus r. It can be fully written as the sum of ar to the power of n-1 from n is equal to 1 to infinity is equal to a divided by 1 minus r. Now, let's do some exercises. We will start with exercises on arithmetic series, then we'll move on to exercises on geometric series. Exercise number 1. Given the arithmetic series, -2, +2, +6, +10, plus the sum of the next consecutive terms until 122. 1.1. Find the number of terms in the series. Since this is an arithmetic series, we have to use the formula for the general term of an arithmetic sequence to solve this problem. We have covered arithmetic sequences in Lesson 1. I'll leave a link to Lesson 1 in the description section below in case you haven't watched it. In order for us to find the number of terms in the series, we first need to find the values of a and d so that we can substitute them into our formula. We are given the series -2, +2, +6, +10, plus the sum of the next consecutive terms until 122. And looking at the series, -2 is the first term. Therefore, a is equal to -2. D is the common difference between the terms, and it is given by t2 minus t1, which in this case is 2 minus -2. 2 minus -2 can be written as 2 minus -2 in brackets. And if you multiply two minus signs you get a positive, so 2 minus -2 becomes 2 plus 2, and it is equal to 4. Now, let's check if it is correct. 6 minus 2 is equal to 4, and 10 minus 6 is also equal to 4. Therefore, our common difference d is equal to 4. The general term of an arithmetic sequence is given by Tn is equal to a plus n-1 in brackets times d. The last term of the series is 122, so let's substitute Tn with 122, a with -2, and d with 4. Now, let's get rid of the brackets. -2 minus 4 is equal to -6. So we now have 122 is equal to 4n minus 6. If we add 6 to both sides of the equation, we are left with 4n is equal to 128. And if we divide both sides by 4, these two 4's cancel each other. 128 divided by 4 is equal to 32. Therefore, n is equal to 32. So we can say that there are 32 terms in the series. (1.2) Write the series in sigma notation. For us to write the series in sigma notation, we will need the general term of the sequence, the upper limit of summation, and the lower limit of summation. Looking at the answer we gave on the previous question, we can see that we have already evaluated the general term of the sequence. And it is 4n minus 6. We also have the upper limit of summation, which is the number of terms or the term at which the series ends. And it is 32. Now, let's write the summation symbol. And now let's write the general term. I'm using the letter k as a variable for the index of summation so that we don't confuse it with the number of terms. Now let's write the upper limit of summation. We know that the first term of the series is -2. So looking at the general term, we can see that the index starts at 1, because if you substitute k with 1, you'll have 4 minus 6, and it is equal to minus 2. So k is equal to 1. (1.3) Evaluate the sum of the series. In order for us to evaluate the sum of the series, we have to use the arithmetic series formula, Sn is equal to n divided by 2 times 2a plus n minus 1 in brackets times d, all in square brackets. N is 32, a is minus 2, and d is 4. So let's go ahead and substitute them into the formula. (32 divided by 2 is 16. 2 times minus 2 is minus 4. And 32 minus 1 is 31, times 4 is 124. 124 minus 4 is 120. And 16 times 120 is 1920. Therefore, the sum of the first 32 terms of the series is equal to 1920. Because we have the last term of the sequence, we can also use Sn is equal to n divided by 2 times a plus l in brackets. N is 32, a is minus 2, and the last term l is 122. So let's go ahead and substitute them into the formula. (32 divided by 2 is 16. And 122 minus 2 is 120. 16 times 120 is 1920. Therefore, the sum of the first 32 terms of the series is equal to 1920. Exercises on geometric series. Exercise number 1. We are given the sum of 3 times 4 to the power of k minus 1, from k is equal to 0 to 9. And we are told to evaluate the sum. This can be a little tricky, so be careful it doesn't catch you out. Looking at this problem, it might seem that a is equal to 3. But that is most certainly not the case. It would be if the lower limit of summation was 1. But it's not. The lower limit of summation is equal to 0, so the series starts with an index of 0. The sum of 3 times 4 to the power of k minus 1, from k is equal to 0 to 9, is equal to 3 times 4 to the power of 0 minus 1, plus 3 times 4 to the power of 1 minus 1, plus 3 times 4 to the power of 2 minus 1, plus the sum of the next consecutive terms until 3 times 4 to the power of 9 minus 1. 4 to the power of minus 1 is equal to 1 over 4, and 1 over 4 times 3 is equal to 3 over 4. Therefore, T1 is equal to 3 over 4. 1 minus 1 is equal to 0. And anything to the power of 0 is 1, so 3 times 1 is 3. Therefore, T2 is equal to 3. 2 minus 1 is equal to 1, and 4 to the power of 1 is 4, so we have 3 times 4 and it is equal to 12. Therefore, T3 is equal to 12. 9 minus 1 is 8, and 4 to the power of 8 is 65,536. 3 times 65,536 is equal to 196,608. Therefore, the last term is equal to 196,608. Now, looking at the series, 3 over 4 is the first term. Therefore, A is equal to 3 over 4. R is equal to T2 divided by T1, which is 3 divided by 3 over 4. Any number has an invisible denominator of 1, so we can write 3 as 3 over 1. If you have a fraction divided by another fraction, flip the bottom fraction and multiply it to the top fraction. If we do that, we are left with 3 over 1 times 4 over 3. Looking at our two fractions, the two 3's cancel each other, and we are left with 4 over 1, and it is equal to 4. You can alternatively use T3 and T2, which are 12 and 3 respectively. 3 goes into 12 4 times. Therefore, R is equal to 4. Now, how many terms does our series have? Our upper limit of summation is 9, and our lower limit of summation is 0. 9 is greater than 0, so 9 minus 0 plus 1 is equal to the number of terms. Therefore, our number of terms, n, is equal to 10. We can now use the finite geometric series formula. Sn is equal to a times 1 minus r to the power of n in brackets divided by 1 minus r. A is 3 over 4. R is 4. And n is 10. Let's go ahead and substitute them into the formula. Four to the power of 10 is 1,048,576. And 1 minus 4 is minus 3. So we have 3 over 4 times 1 minus 1,048,576 in brackets, all over minus 3. 1 minus 1,048,576 is equal to minus 1,048,575. So we are left with 3 over 4 times minus 1,048,575 divided by minus 3. The two minus signs cancel each other. And 3 can be written as 3 over 1. So we can take 3 over 1, flip it, and then multiply it with 3 over 4. 1 times 3 is 3, and 3 times 4 is 12. So we have 3 over 12 times 1,048,575. 3 over 12 can be simplified further because 3 and 12 are both multiples of 3. So if we divide both 3 and 12 by 3, we will end up with 1 over 4 times 1,048,575. Dividing the numerator and the denominator by 3 will have no effect on the value of our fraction, because it is the same as taking 3 over 12 and dividing it by 3 over 3. 3 over 3 is equivalent to 1, and dividing or multiplying anything by 1 won't change its value. 1 over 4 times 1,048,575 is the same as 1,048,575 divided by 4. And 1,048,575 divided by 4 is 262,143.75. Therefore, S10 is equal to 262,143.75. Exercise number 2. Given the sum of 3 to the power of 2k minus 1, from k is equal to 1, to n, is equal to 22,143, Find the value of n, the number of terms of the geometric series. Looking at this problem, we are given the value of the sum of all the terms, and it is 22,143. We need to determine the values of a, the first term of the series, and r, the common ratio, so that we can plug them into the geometric series formula. The lower limit of summation is 1, so the first three terms of our series are 3 to the power of 2 times 1 minus 1, plus 3 to the power of 2 times 2 minus 1, plus 3 to the power of 2 times 3 minus 1. 2 times 1 is 2, and 2 minus 1 is 1, so our first term is 3 to the power of 1, and it is equal to 3. 2 times 2 is 4, and 4 minus 1 is 3, so the second term is 3 to the power of 3, and it is equal to 27. 2 times 3 is 6, and 6 minus 1 is 5, so the third term is 3 to the power of 5, and it is equal to 243. The sum of all the terms, Sn, is given to us and it is equal to 22,143. The first term of our series is 3. Therefore, a is equal to 3. r is equal to t2 divided by t1, which is 27 divided by 3, and it is equal to 9. We can now use the finite geometric series formula, Sn, is equal to a, times 1 minus r to the power of n in brackets, divided by 1 minus r. Sn, is 22,143. A, is 3. And r, is 9. Let's go ahead and substitute them into the formula. One minus 9 is equal to minus 8. So we have 22,143 is equal to 3 times 1 minus 9 to the power of n in brackets divided by minus 8. Let's get rid of the minus 8 by multiplying by minus 8 on both sides of the equation. If we do that, these two minus 8s cancel each other. Minus 8 times 22,143 is equal to minus 177,144. So we now have minus 177,144 is equal to 3 times 1 minus 9 to the power of n in brackets. If we divide both sides of the equation by 3, these two 3's cancel each other. Minus 177,144 divided by 3 is minus 59,048. So we have minus 59,048 is equal to 1 minus 9 to the power of n. Now, let's move minus 9 to the power of n to the left, and minus 59,048 to the right. Doing that changes their signs. And we are left with 9 to the power n is equal to 59,048 plus 1. (59,048 plus 1 is equal to 59,049. Because we are working with big numbers, we have to use logarithms to solve for n. I am aware that we haven't done logarithms on the previous lessons, so allow me to introduce only one property of logarithms for the purpose of solving this problem. We will take a closer look at the rest of the properties in lessons to come. If z is equal to y to the power of x, then x is equal to log base y of z. Remember this property. It's going to come in handy when you want to solve equations involving exponents. Now using that property on our equation, we have n is equal to log base 9 of 59,049. Log base 9 of 59,049 can also be written as log 59,049 divided by log 9. And log 59,049 divided by log 9 is equal to 5. Therefore, n is equal to 5. Exercise number 3. Given the infinite geometric series, 4 plus 3 plus 9 over 4 plus 27 over 16 and beyond. 3.1. Write the series in sigma notation. In order for us to write the series in sigma notation, we will need a, the first term of the series, and r, the common ratio. 4 is the first term. Therefore, a is equal to 4. R is equal to T2 divided by T1, and T2 divided by T1 is 3 divided by 4. Therefore, R is equal to 3 over 4. Now, let's write the summation symbol. Now let's write the general term. This is an infinite series, so let's write the sideways 8 symbol as our upper limit of summation. Our lower limit of summation is equal to 1 because the series starts with an index of 1. Therefore, k is equal to 1. (3.2) Evaluate the sum. The sum to infinity is given by a divided by 1 minus r, where r is between 1 and minus 1. A is equal to 4. And r is equal to 3 over 4. But, does the series converge? Yes it does, because 3 over 4 is between 1 and minus 1. 3 over 4 can also be written as 0.75. And 0.75 is a number that is clearly between 1 and minus 1. So we can say that 3 over 4 is between 1 and minus 1. Now, let's substitute our a and r into the formula. Our denominator now contains another fraction that we need to take care of. Let's turn 1 into a fraction by writing it as 1 over 1. At the top, we still have 4. But at the bottom, we have two fractions separated by a minus sign that we need to manipulate. This 4, multiplied by this 1, is equal to 4. This 1, multiplied by this 3, is equal to 3. And this 4, multiplied by this 1, is equal to 4. So we have 4 minus 3, divided by 4 at the bottom. 4 minus 3 is 1, so we are left with 4, divided by 1 over 4. The 4 at the top can be written as 4 over 1. So we can take 1 over 4, flip it, and then multiply it with 4 over 1. If we do that, we'll have 4 times 4, and it is equal to 16. Therefore, our sum to infinity is equal to 16. We have reached the end of the lesson. Please like and subscribe if you've enjoyed this lesson, learned something new, or if you want us to continue making these awesome videos. Let us know which topic you are struggling with the most in the comment section so that we can get you sorted. Also follow us on Twitter, Facebook, LinkedIn, and Instagram so that you can stay updated with regards to all things mathematics. Thanks for watching. Goodbye.